Hello everyone, I am here with the solution of problem 3 of electrostatic chapter of a book written by David J. Griffith. So let's read the problem first. Find the electric field a distance z above one end of a straight line segment of length L that carries a uniform line charge lambda. Check that your formula is consistent with what you would expect for the case z more greater than L. Sorry everyone, I can't find the lambda sign on keyboard, so I'll write it here like this. So let's go for the solution. So for better understanding of the problem, we will draw a image first. So I take a straight line segment of length L, and at the end of this line we will take a point called P. Actually here we have to find the electric field. So we place this system on a coordinate system. Here L line, the line of length L placed on x-axis, and the point P where we have to calculate the electric field placed on y-axis. So now we will take a small line element called dx. It is as small as you can think it as a dot. Okay, and now we will join the both point dx and P, and the dx is placed on a at a distance x, obviously from the origin O. So let's write down what we have done with this image. Okay, so we write here what we actually done with this figure. So let us consider a line element dl. What we already done, sorry, it will be dx. So let us consider a line element dx, what we done, and at the distance x. So at the distance x from the origin from the origin as shown in figure. Now we will calculate the magnitude of the electric field at P due to dx. So let's calculate. So d e, obviously a vector, and magnitude 1 by 4 by epsilon naught into lambda dx divided by x square plus z square. So let's understand what I write. dE, actually we calculate the electric field at P with the respect to dx. For now we will calculate the electric field for the whole segment, but now we calculate for dx. So the electric field must be dE. We take the magnitude, so it is 1 by 4 pi epsilon naught into lambda dx divided by x square plus z square. Lambda is described in this question, and z, the distance between the origin and the point P, and it is x square plus z square. It's a formula, we all know that. And now we will discuss the electric field at P due to dx with the direction. Before we calculate the dE with the direction, let's see something with this image. So this is the direction of dE, right? And the line between dx and P make an angle theta with the x-axis, okay, and it is basically dE. So we divide it into two components. We know this rule, and this is theta, because this is x-axis and this line make with this theta, and this line is parallel to the x-axis, so this line will make the same angle with this line, that is theta. So we can write E cos theta. We know from the vector division rule, it will be TE, and this component is DE sin theta. As we can see, DE cos theta is opposite to x-axis, so this is directed towards minus I cap, okay, because the x-axis is direct with I cap, so opposite to it will be minus I. So actually what I write here, I write dE 1 by 4 pi epsilon naught lambda dx by x square plus z square minus cos theta I cap plus sin theta j cap. We know from the vector rule that this line is the summation of this line and this line. So what we actually done, so it is basically dE equals to dE sin theta j cap and plus dE cos theta I cap minus I cap, because it is in the opposite direction of x-axis, and dE minus cos theta I cap plus sin theta j cap. What I actually do it here, I just put the value of dE here and write this. And here I calculate the value of cos theta and sin theta using the formulas of trigonometry. So cos theta is x divided by root over x square plus z square, and sin theta is z divided by root over x square plus z square. And now we will calculate the electric field at P due to this whole segment of length L. At first we will put the value of sin theta and cos theta in this equation. Let's make this equation number 1. So we will put the value of cos theta and sin theta in this equation 1. So here we put the value and we get this figure. Now we will modify this figure. So what I have done is I multiplied this 1 by x square plus z square with this 1 by root over x square plus z square, and I get x square plus z square to the power 3 by 2, and here also. So now we will calculate the electric field at P due to the segment of L. So for this whole length we will calculate electric field at the point P. So here electric field at P due to the segment of length L we're gonna calculate. So E equals to lambda by 4 pi epsilon naught 0 to L minus x by x square plus z square to the power 3 by 2 I cap plus z by x square plus z square to the power 3 by 2 j cap. So here is limit is 0 to L, because in the picture we can see that it starts from 0 to L because the length is L according to the question. Now we integrate the part x by x square plus z square whole to the power 3 by 2. Now we take x as z tan phi. So dx equals to z sec square phi d phi, and from here to here tan phi equals to x by z, and from the formula of trigonometry we can calculate sin phi from tan phi and cos phi to sin phi. Like tan phi equals to x by z, then tan square I write it as a t, so tan square phi equals to x square by z square. Then sec square if tan square equals to x square by z square, then sec square equals to obviously z square plus x square by z square. Then cos phi equals to cos square z square by z square plus x square, and cos phi equals to z by root over z square plus x square, and then sin phi equals to x by root over z square plus x square. So that's how it's work. So here we put the values, the value of x, z tan phi, and dx z sec square phi d phi, and x square equals to z square tan square phi, and z square is as well z square, and here z square tan phi and sec square phi, and we make the z out of the bracket and it became z cube, like z square into 3 by 2. So it became z cube. Here z cube, and tan square 5 plus 1 equals to 6 square. So 6 square into 3 by 2, and it became sec cube. Now the further calculation is here. Tan phi equals to sin phi by cos phi. 1 by sec phi equals to cos phi. Now the integration of sin phi. As we know, integration of sin phi is cos phi. So sin phi equals to minus cos phi, and minus cos phi and minus cos phi became, so left cos phi into 1 by z, and the value of cos phi we already solved that, the value of cos phi, so I just put the value of cos phi here and do the calculation. So 0 to L, sorry, it will be 0 to L. So 0 to L, and from here we can write this, and 0 to L we put the limit, and after putting the limit the value became like this. Now go for the second integration, that is z by x square plus z square to the power 3 by 2 into dx, and again we put the value of dx and x square like the previous one. We make this z at here, and now we do the calculation again. Integration of cos phi is sin phi. From here again we can write the value of sin phi, and now I just put the limit on it, 0 to L. After putting the limit, it's like this. And now from equation 2, so our equation 2, it is 0 to L limit and this, and we do the integration of this and this and this at here and here. So we just have to put the value together. So I just basically do the sums of two integration, and here we get the value, and this is our answer. This is the electric field at point P here. So this is my video. Hope you like it. If you really like it, then hit the like button and subscribe my channel. Thank you.